Hi, in this video we have a question from Leningrad Mathematical Olympiad year 1963. The question says, for what value of n we have an answer for the following equation. 2 power n plus 1 is equal to a power m. N, m, and a are all natural numbers and m is larger than 1. So maybe I spend 5 to 10 minutes try to solve this exercise and then come back and see the solution. Alright, let us see how we can solve this exercise. Obviously, we can take the 1 to the other side. So a power m minus 1 is equal to 2 power n. And we can decompose a power m minus 1 into a minus 1 times a power m minus 1 plus a power m minus 2 till a power 0, which is 1. And that should be equal to 2 power n. And because these are two factors that we multiply together and they become 2 power n, it means each of them should be a factor of 2 power something, 2 power k. So in that case, for example, a minus 1 becomes 2 power k, and the other one should also be a factor of 2. If one of them is 1, for example, if this is 1, that means a has to be 2. But this is contradiction because we have here is an odd number, on the right side it becomes an even number. So this is not possible. Therefore, this has to be something that is larger than 1. And in this case, okay, it's 2 power k, which we don't know what the k value is. Anyway, we can take 1 to the other side. That means a becomes 2 power k plus 1. And that means a is an odd number. Important information. So we know that m is larger than 1. This is given in the exercise. And we can now look at this second part of the decomposition. We have a power m minus 1 plus a power m minus 2 till 1. And because m is obviously larger than 1, that means this section is larger than a minus 1. Anyway, this is not important. What we have is that this term, if you look at it, it's composed of addition of several numbers. And each of these numbers are an odd number because a is an odd number. And we know that this has to be 2 power something. Because this is 2 power k, this has to be 2 power n minus k. Okay, we know a is odd, so all the terms here are odd numbers, and addition of these odd numbers, it becomes an even number. Therefore, the number of these odd numbers has to be an even number. And the number of these are equal to m. That means m has to be an even number. So m is equal to 2q. This is very important information that we extracted. So we look at the exercise again. So a power m minus 1 is equal to 2 power n. But in this case, we know that m is equal to 2q. So I can put it there. And now I can use the other algebraic identity to decompose this. So a power 2 minus 1 is equal to a minus 1 times a plus 1. So we can apply that to this. It becomes a power q minus 1 times a power q plus 1 is equal to 2 power n. Let's call this a power q equal to s. That means s minus 1 times s plus 1 is equal to power n. And now we can actually solve this very simply because s minus 1 should be 2 power n1 and s plus 1 should be 2 power n2. We can subtract these two from each other. Therefore, 2 from the left side becomes equal to 2 power n2 minus 2 power n1. And obviously, we know that n1 is less than n2 because this number is smaller than this. Which means we can factorize 2 power n1 from this equation. So if we factorize 2 power n1, it becomes 2 power n1 times 2 power n2 minus n1 minus 1 is equal to 2. Since this is an odd number, that means this has to be equal to 2. And that means n1 is equal to 1. So if this is 1, this disappears. That means this is 1 plus 1 is 2. So this power should be equal to 1. n1 is 1. Therefore, n2 should be equal to 2. Okay, so we have obtained already a lot of information. n1 is 1. I can put it here. Therefore, s becomes 3. And s is equal to a power q. So a power q is equal to 3. If a power q is equal to 3, that means a is equal to 3 and q is equal to 1. And we know that m is equal to q, therefore m is equal to 2. So 3 power 2 is 9, minus 1 is 8, therefore n is equal to 3. That's conclude the solution of this exercise. Let's see what we have learned. know well-known algebraic identities and be able to apply them to factorize and decompose algebraic expressions. This is very important. We use two of them in this exercise. Check whether a number is odd or even and use this property to obtain additional information. This is also very important. Sometimes by looking at these simple facts, you can extract an extra information which helps you to proceed with the solution. All right, so that's the end of the video. See you next time. Bye.